Alright. So I got this thing working alright. Really wish we could get that thing going. Okay, so
That's a thing.
we closed out chapter 6 last time with going through all of the various policies and government interventions. And now we're going to get into the wacky world of measuring happiness. That's our charge today. So, I know there was quite a few of you with some student athletic type of stuff going on Monday. Make darn sure that you get your notes from somebody. We spent the whole hour going over this little worksheet thing. The explanations for it are all here, and then we filled in a whole bunch of stuff that you really need to spend the same amount of time we did in class probably going over it on your own. Because you will see a test question about that coming up a week from today when we have our first in-class quiz covering material that we've done up to this point. So we've been doing the online tests. The next one of those is due on Tuesday, similar to before, kind of on your own schedule, covering chapters 5 and 6. And then we'll have Wednesday an in-class test that'll have some short answer problems. And I will give you more information on practice and what to do for those and some practice problems to prepare prior to that. So, yes?
When can we start taking the chapter 5 and 6 tests?
I allowed it to go as of now.
Okay.
It is open. Okay, so 5 and 6 are open with the same format as before, 3 attempts, all that. And then chapter 6 homework is open due Sunday. So you've got some time, but don't save it all to the end. We've got a lot of stuff we're hitting. Next week is a short week for us. Remember, we do not have class Friday. So we're going to end with our in-class quiz on Wednesday. So I am shortening up the material, you might like to hear. We are going to skip chapter 9, but we're going to cover chapter 8 starting now.
I actually covered 8.
All right. So, any questions? So, the wacky world of happiness, according to an economist, starts with utility functions that we believe you all possess. So, you guys all have a little happiness function, and that's what this chapter 8 is all about. So, measuring happiness. Alright, so it's kind of a weird thing. How the heck could we have a little calculator to figure out how to start measuring happiness? So we're going to associate some numbers to happiness. So one of the key things that we're going to have here, some assumptions that we make, aren't even too strenuous for an individual. So one of those assumptions is that you have the ability, an individual has the ability to rank his or her preferences. Another assumption that we make is that more is preferred to less. More is preferred to less. In general, we give you the opportunity to throw something in the garbage can if you don't want. But if we give you more sodas, you are happier. So The first soda, the second soda, the third soda, the more I give you, the happier you are. Now, the relationship of your happiness to the amount that you're consuming, that's a different story. We're going to spend some time on what that looks like. But in general, more is preferred to less. Okay, so with those things here, let's just jump right into an experiment. Let's suppose we've got, so this is an example. Suppose there are 4 bundles of goods. Bundles A, B, C, and D. In bundle A, we've got 4 pizzas, 2 M&Ms, and 5 beers. That's one bundle. Bundle B contains 3 pizzas, 6 M&Ms, and 7 beers.
That'd be bags or singular M&Ms.
Bag. Yeah, we'll make it a bag.
It's just 6 and it seemed like a fair question.
C.
No.
Bundle C has 2 pizzas, 2 M&Ms, and 4 beers. And finally, bundle D has 6 pizzas, 6 M&Ms, and 5 beers. So 4 different bundles. What I want you to do next is to look carefully at all of the bundles. Once you guys get them all down. So bundle D is 6 pizzas, 6 M&Ms, 5 beers. Look carefully at each one of those bundles and rank them yourself. Look at the bundles, think about how you like these 3 goods, and come up with an ordering. So on your page for yourself, put your name, so you can put Russ, put your name, not my name. I probably should wrote your name. And then just put your ordering. Like, I think I would go C, B, A, D, or D, A, B, C, or whatever. So I want you to order these according to your preferences, not your neighbors. You guys look at that and come up with a preference ordering. I'm going to give you a minute to do that, and then I'm going to randomly select some of you to come to the board and share your work.
Are we to assume they all cost the same, or are we not putting that into a factor?
Price is not a factor.
Gotcha.
Yep. Just the quantities of the goods are the only thing we're focusing on. Okay. Let's see. Kelty, pick a number between 5 and 10.
8.
8. Let's see. We got 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and put your first name on the board and your preference ordering. 1, 2, 3, 4, 5, 6, 7, 8. Chance.
So 8 was the good number?
Go to the board and put your preference ordering up there. 1, 2, 3, 4, 5, 6, 7, 8. Somehow we landed on you, Kelty. Aren't you lucky?
Oh, okay.
Here's your marker. You want to catch? Ooh, almost hit that one. All right. 1, 2, 3, 4, 5, 6, 7, 8. All right, so just, yeah, you don't have to be lined up or perfect or what. Yeah, I guess as long as we're doing that, that's fine.
Just really like my name's okay.
And then you guys can grab your chairs. Okay. So here's our preference orderings by our 4 people, our 4 human beings. First of all, I want to point out that they were all able to do it. Nobody came up here and said, sorry, I can't do it. You know, I just can't decide. There's no way I could possibly decide. So we were able to rank their preferences for starters. Now, let's dig a little bit deeper and see, how did this one go? More is preferred to less. Does anybody's preferences up there not fall in line with that?
Sean.
Sean, let's see. Sean, what did you do here? C is preferred to A. So what's wrong with that?
You get more.
Okay, so you had C over A. Can I ask what you're thinking with C over A? Didn't want more of any of those. Okay, so in general, when you have excess items, if there's no storage cost, it's not going to hurt you at all. Do you like to give to charity or church or other people once in a while? So you could give the excess away as kind of a nice thing to do with excess, right? So you don't necessarily have to consume them yourselves. All right, so that's that part of it, that we had that going on. So we got the D's here. Everybody else seemed to be on the D camp. And then we have some differences. We got Chance going with A, Kelty and Katie going with B. So what's going on there? What's the story in their lives? What's their personalities, their preference profile? What does that mean? What is that telling you? What's that?
They like M&Ms.
M&Ms. Who's they?
Kelty and Katie.
All right, Kelty and Katie. And so what does that say about Chance?
He likes pizza.
Pizza? Okay. So you see how we're starting to get a little look at the consumer by this little survey. We're starting to get a glimpse of what these people are like and what they don't like, right? By thinking about their ability to rank their preferences. All right, so Kelty and Katie came up with the same ordering. Kelty, if I put a number of 100 on your bundle D, I want you to put a number on B. The lowest it could be would be 0. The highest it could be would be 99 because you prefer D to B. If you like it about half as much, it would be probably 50, right? So I want you to place a number on bundle B relative to bundle D. Like, where is that for you? Is it close to bundle D? Is it kind of far away?
Like 78.
78. All right, and let's go ahead. How about bundle A? Where does that fall for you on your meter?
40.
40. And bundle C?
20.
20. Okay, so with this, would it be fair to say, Kelty, that if you thought even harder about it, that you like bundle D about 5 times as much as bundle C? So she might not have exactly did that quantitatively in her head, but you see how we're using the numbers now to quantify her preferences in kind of a way that allows us to see how much more she likes bundle D relative to bundle C. All right, Katie, let me do the same exercise with you. Give me a bundle D.
I'd say
50. 50. Now, let me stop there for a moment. Kelty has a 78, Katie has a 50. Can we say that Kelty likes bundle B much more than Katie likes bundle B?
Depending on how much they like bundle D.
Okay, so relative to bundle D, so we can say that Katie likes bundle B half as much as bundle D, but can we say that Katie likes bundle B half as much as Kelty likes bundle D?
No.
No. You see, the problem I'm running into is that I can't compare preferences across people using these numbers. But the numbers are pretty solid within a human being. So when we think about preference functions or utility in the way that we're using the numbers that we're generating, it's kind of sound and logical to say Kelty likes C or C 5 times less than B or vice versa. But we can't start crossing these numbers between each other. And in fact, these numbers are somewhat arbitrary. I could have said, Katie, let's say that this one's worth 1,000. What's this one worth? And if she was keeping the same line of logic, it'd be 500. And the same is true, we can't say that she likes bundle B 5 times more than Kelty likes bundle D, right? So it doesn't make any sense when we start going across human beings, even though it makes maybe perfect sense within a human being. All right, so that's the direction we start to head with what economists call utility functions. So this is some mathematical formula that some economists would say, I can describe Kelty's function with some equation. She's got some equation in her gut that tells her how she likes things. And she's able to express that with numbers, which then I could describe that mapping of preferences with some sort of formula. So it's possible to start to tie mathematics back to this. All right, well, we're not going to get that crazy and actually start to derive what that formula looks like, but we're going to keep that in mind as we start to map this out graphically on looking at preferences. All right, let me pause there for a second. Questions or comments? So already, I hope I've brought you someplace that you never imagined you'd go, that we're able to start quantifying happiness with numbers, right? And we're actually starting to put a little meat on the bones compared to where we started with, when it's all kind of willy-nilly. Well, I like this one better. I like pink better than blue, and I like this and this. So all of a sudden, we're starting to crank things down. All right, so let's put a couple definitions up then to motivate this a little bit more. So economists refer to this happiness function as utility. Total utility, TU, is the total satisfaction derived from consumption. So from our example even, we might say that the total utility for Kelty, let's put a little K down there, is equal to Kelty's total utility she gets from, let's see, we'll go to Kelty's bundle D here. 6 pizzas, so we got pizza utility, plus the utility she gets from M&M's, plus the utility she gets from beer. And so now we've got a formula here, potentially, where we can start to pick apart the total utilities we had even further. So we could go back to Kelty and say, well, how much satisfaction do you get from 6 pizzas or 6 M&Ms? And she'd say, 46, 63, and 74, if we really started putting things down. And we could come up with a number that reflects her total satisfaction derived from consumption of goods. Okay, questions on that at all? Now, probably more important than total satisfaction is marginal satisfaction. So marginal utility is the satisfaction gained by an additional unit of a good. The satisfaction gained from an additional unit of a good. So for this one, I want you to imagine mowing the lawn. I hope all of you have had the opportunity to mow the lawn. I know maybe for some of you, maybe one person in your family did it more so than others. But I want you to imagine that super 100-degree, 98% humidity day, and you had to go mow the lawn because it's your job. And you've got a pretty good sized lawn, so you've been out there for an hour, hour and 15 minutes. So imagine that, the sweat's pouring down, you're drenched, you go inside, you open up your refrigerator, and you grab your favorite beverage, which is for you a what?
Lemonade.
You grab what you want, and I want you to really imagine that first gulp. The satisfaction that you get from that first gulp. Okay? Just imagine what that happiness meter is jumping up to. Now, I want you to think about your second gulp. How did the second gulp compare to the first gulp? Did your happiness from the second one go up or down? Up? So the second one was better than the first. That's okay if it is. Let me move on to the third gulp. Gulp, gulp, gulp. That third gulp, what happened with the third gulp relative to the second gulp? How did that go? Same? How about the fourth gulp? How did the fourth gulp compare to the third gulp, compare to the second gulp, compare to the first gulp? So, what's happening to each additional gulp, the satisfaction that you're getting, and you can keep drinking as long as you want and start looking at the 25th gulp and the 26th gulp. What eventually happens to the utility derived from the additional gulp? It diminishes. It goes down. That is an important law in economics. We talked about the law of demand, the law of supply. This is the law of diminishing marginal utility. As you consume more and more of a good, the additional amount of utility that you derive from additional units will eventually fall. And that's ultimately, by the way, where the downward sloping demand curve comes in. So mowing the lawn. First gulp versus the second versus the third versus the fourth. That's the idea. Eventually, the satisfaction of an additional gulp falls. And that is the law of diminishing marginal utility. All right, so I guess I can write that here. I'll define it up there. The law of diminishing marginal utility runs something like this. As you consume more and more of a good, the utility that you derive from each additional unit eventually falls or diminishes. So, flipping on our graphing goggles, I want to measure the quantity of a good down here, so that's your gulper. You guys put whatever your favorite beverage here, but the quantity of gulps. And on the vertical axis, I'm going to measure utility this time. So this is that happiness meter. So over here, we're going to measure utility. In general, what does that function look like? let me give you a couple possibilities here. Does it look like A, B, or C? C. For what function? The total utility function or the marginal utility function?
Marginal.
The marginal. What does the total utility function look like? A, B, or C?
A.
A. So as more is preferred to less, so as I consume more and more of a good, I get happier. So my total utility function looks like A. My marginal utility function looks like C. All right, so let me push you a little bit harder then on the total utility function. You guys can rewrite this. If you wrote the ABC thing down, just rewrite this graph again. Does the total utility function look more like this, this, or this? A, B, or C?
C.
C. Why?
Because the more and more you consume, the less.
All right, it follows this law, right? So as you consume, you're adding, so it's a positive relationship. Happiness is getting bigger, but at a diminishing rate, right? So it's increasing at a decreasing rate is this C function. So this ends up looking, this is the shape that we'd expect following the law of diminishing marginal utility. The total utility function would look like C. All right, so you guys can redraw that again. So ABC, it looks like C. Let me do one more here. Kind of bridge the two concepts together, hopefully. So it's possible that we could have some increasing returns maybe early on, but I'm just going to draw it kind of generically like this. There's the total utility function of gulps of this beverage. So 1 gulp, 2 gulps, 3 gulps, 4 gulps, 5 gulps. 1, 2, 3, 4, 5. 5 gulps makes me happier in total than does 2 gulps, because I'm getting more of the good, so it's going up. But if we now break down a little more carefully the utility derived from each additional unit, and I think about the first gulp gave me, let's say, 100 units of satisfaction. 2 gulps gives me maybe 140 units of satisfaction. 3 gulps, we jump up to 170 units of satisfaction. 4 gulps, we're up to 190. And finally, with 5 gulps, we're at 200 units of satisfaction. So if we start to think about the marginal unit, the first one gave me 100 units. The second one only added 40. So that would be the area of this little rectangle if we were doing that, right? 1 unit, the additional unit, the second unit added 40 units of satisfaction. And the third unit added 30 units of satisfaction, going from 140 to 170. 20 units for the fourth, and finally just 10 units for the fifth gulp. So the areas of these little green rectangles represents marginal utility and captures the concept of the law of diminishing marginal utility. The area of the rectangle, the little box, is getting smaller and smaller and smaller and smaller. All right, let me let you catch up to that. Anybody have any questions there? So, time to flip on. We had little equation goggles on, little baby ones, and then we went graphing goggles. Now I want you to flip on your schedule goggles. And most of your problems in your homework are going to probably reflect these schedule goggles. So, let's do an example with beer and pizza. You want to substitute in your favorite beverage instead of beer, that's fine. I'm pretty sure most of you are into pizza. Even if you're lactose intolerant, maybe you got no cheese on it or something. So you can have some version of a pizza. All right, so over here we're going to put, and by the way, I'm going to have about 6 columns worth of data. So leave yourself enough room. Start over to the left-hand side. And this is going to be the quantity of beer. And then we're going to start at 0, 1, 2, 3, 4, 5, 6. And then we're going to look at the total utility from beer for this particular person. Is 0 beers, 0 utility. 1 beer jumps us up to 40, 2 to 60, 3 to 70, 4 to 75. At 5, we've got 73 units. And at 6, we've got 63. So now, using the schedule of numbers, what is the marginal utility associated with the first beer? 40. The first one here is kind of undefined, so you can put a little slash there. The second beer? 20. All right, so now we're starting to do this, right? We're adding 10. The third beer gives me 10 units of satisfaction, going from 60 to 70, 5. And then what's going on down here?
-2.
We're actually losing a little, which is a little strange.
-10.
And -10. All right? So, there's our schedule of numbers that way. Next column, I want quantity of pizza. And we're just going to keep it easy and go 0, 1, 2, 3, 4, 5, 6. Now we're thinking slices of pizza. And the total utility from pizza, 0 pizza, 0 happiness. Our first slice, we ramp up to 20 units of satisfaction. With 2, I've got 34. With 3, I've got 44. With 4, I've got 50. With 5, I've got 54. And with 6, I've got 57. All right. You guys do the marginal utility column this time. I'll help you out with the little dash on 0 there. No marginal utility. Got it? Got it? Got it? Looks like everybody's tracking. Good, good.
Better restart.
All right. So, if you guys go to a party and there is unlimited beer and pizza, what is your optimal bundle of beer and pizza to consume at the party that night?
Are we assuming that we're this person?
You're this, yes, assuming you're this person. What is the optimal quantity of beer and pizza for this person?
Put all the cap off.
Number 3.
How many here?
4 beers.
4 and
6 pizzas.
6, right? Yeah.
He's not full yet.
Yeah, he's not full yet. We haven't reached that stage. Okay, so if beer and pizza are free, then to maximize utility is pretty easy. You just keep going up to this satiation point, right? So if you're Paris Hilton and you have unlimited funds to buy anything your little heart desires, then utility maximization is pretty easy, doesn't it? Doesn't really matter what things cost. I can just go get it. So that's how you maximize utility in that world. How many of you live in that world? The Paris Hilton world or the super richness world? Not too many of us. So it becomes a lot more interesting when we are constrained by a budget. So our next factor to enter into this is to look at a budget constraint. And there's a couple things, two main things to the budget constraint. Your income, how much money you have to spend, and the prices that the market has in the goods you want to consume. So you don't have the luxury of setting the price. You go to Pizza Village and they say that the dentist is $13.99, that's your price. Depending on how big your budget is, you can buy 2 of them, 3 of them, 4 of them, 5 of them. You got to make choices. So life becomes a little more difficult when we have a budget constraint. So the real consumer problem is to try to maximize utility subject to a budget constraint. So let's write that down. I'm going to just squeeze it in here. So this is called the consumer problem. The consumer's problem, in words, is to maximize total utility. Try to maximize total utility by choosing quantities of goods subject to a budget constraint of fixed income and prices of goods. Okay. So let's do it. Let's suppose that our income, example, suppose that we've got $10 and the price of pizza and beer, our price of beer, a glass of beer is running $1 and the price of a pizza is $2. Now, work with your neighbor or a couple neighbors, work in small groups, and solve the problem again. How do we maximize utility given this preference set of what we've been looking at? Can we afford what we were doing before? I guess let's start there. Can we afford 6 and 4? No, too much money. So go ahead and solve for the optimal quantity of beer and pizza subject to income of 10 and prices of 1 and 2.
4 beers and 3 pizza.
Yeah, buy 4 beers first.
Oh no, what is it? 4 beers,
And afterwards.
3 pizzas. So that's total utility of
Your relative satisfaction per beer is higher than your product satisfaction per pizza. I got an 85 before we adjusted my score, so. Right.
What's that? You can't have a half.
I'm not sure.
And it'll turn out not to matter for this particular problem, but I'll talk about that later.
I did the math. What did they get?
So, I want to hear, now that you've had time to mumble a little bit with your neighbor, what's your strategy? How are you going about figuring this problem out? I think there's a couple different ways to go about it. What's your strategy?
Somebody likes beer, so buy the beer first.
Buy the beer first. Okay, now that's the part I was talking about. Think about where you want to spend your first dollar or your first amount of money. Would I rather have my first beer or my first pizza? What would I rather have, my first beer or my first pizza?
Beers.
Beer. Okay. Now, what would I rather have, my second beer or my first pizza?
Second beer.
Second beer. All right, so that's the logic that we can start to think about here, is how do I optimally spend my money? If I go here, my satisfaction that I get from the first beer is 40. The first pizza is 20. Go where the happiness is, right? So I'm going to pick up my first beer. Should I get my second beer or my first pizza?
Second beer.
Second beer, why?
Because you get
Same.
6.
It's
So
cheaper.
it's the same?
It's already at the bar.
But it's cheaper.
Yeah,
But it's cheaper. Oh, you're bringing cost into it already.
$1.02.
It's the same happiness, but you're spending less money for the same
More bang
happiness.
for your
So.
buck.
All right, so now you guys are bringing up a couple important points. First of all, let me do number one. When it's a tie like this, with beer and pizza, I can't remember which economist came up with this, but you always go with the beer if it's a tie. I don't know why. I can't remember what the circumstances were, but whenever there's a tie, it goes to the beer. Beer wins. It's kind of like tie goes to the runner in baseball type of thing. I don't know. So you always go with the beer. Now, you brought up probably a more important point, though, of thinking about the dollars, right? So when I look at these two goods, it's not quite fair to look at the first pizza versus the first beer. Why, in terms of dollars? It's twice as much for the pizza. So how could we level the playing field? How could we make it a fair number? So what we're saying is that it's not fair to look at the first pizza that cost me $2 to get $20 worth of satisfaction, or 20 units of satisfaction, and here it took $1 to get 20 units of satisfaction. How could I level the playing field?
So we get like satisfaction per capita person.
Yeah, not per capita, but per
Dollar.
dollar. And how would you do that? What would I need to do to 20?
Divided by 2.
Divide by 2, because what's 2?
$2.
It's the price of the good. So now we're getting 10 units of satisfaction for every dollar that we spend. So I want you to add another column. I should have told you there might have been an extra one here. The marginal utility of pizza divided by the price of pizza gives you 20 divided by 2 equals 10 units of satisfaction per dollar. 14 divided by 2 for the second pizza gives you 7 units of satisfaction per dollar. All right, tracking with that?
Yep. Right.
So then you just divide all these through by 2 all the way down.
1.5.
And we do get down to 1.5 units of satisfaction there. Now let's go back, after you guys get that down. What do I want, my second beer or my first pizza?
Second beer.
Now I want my second beer, because, by the way, beer happens to be $1. so this on a per dollar basis is the same number, right? So we're doing kind of the same thing for both goods. And so I want my second beer. Third beer or first pizza?
Third beer.
Third beer, just because of that little rule that says always go with the beer. But technically, all kidding aside, the consumer is actually indifferent between these two, right? It's kind of a coin flip. Like, give me one, give me the other, I don't care. You guys have been in that position before, right? We all have that internal trade-off that says, well, if you give me X of these, then I'll give up Y of these, right? That trade-off, that point of indifference is an important one. And so technically, between beer and pizza, it's really a coin flip, but we'll fall back to the Russ rule of go with the beer. Fourth beer or first pizza?
First pizza.
Now we jump into pizza, right? We're jonesing for some grub, and so now we get our first pizza. Fourth beer or second pizza?
Second pizza.
Second pizza. 7 units of satisfaction per dollar is greater than 5 units of satisfaction per dollar. Fourth beer or third pizza?
Get the beer.
Fourth beer.
Take the beer, but it is a tie. Now, let's hold on and do one thing that we haven't done so far. We're kind of having fun. I think we get the utility per dollar thing going. We kind of go back and forth. We teeter back and forth at the margin between beer and pizza, always leveling the playing field of where I get the biggest bang for my buck. Right? Bang for your buck, utility per dollar. But what do I have to be careful of as I'm starting to
How much money you got left?
How much money you got left? How much have I spent so far?
$8.
$8. I still have money left. I have to stop when I run out of money. But that's the process that I'm going through, is spending my money, keeping the marginal utilities per dollar equal as I go along. And so, what am I going to spend next? My third beer or my fifth beer or third pizza?
Third pizza.
Third pizza, and now
We're
I'm
done.
out of money. I've spent all my money. Now, Austin, you asked about a half unit. Can we do that? No, we can't. We can in theory, but we can't if we run into having to buy fixed units. So, for your guys' problems, I'm not going to throw a wild card at you like that. So the last thing I want to leave you with, don't pack up yet, is what we just did, because this is probably the most important part of the lesson, and that is the utility maximizing condition. The utility maximizing condition. And double underline the condition. This is what needs to be held true to know that we maximize utility. When the marginal utility of pizza divided by the price of pizza is equal to the marginal utility of beer divided by the price of beer. In the consumer optimal bundle, for the optimal bundle, the solution to the problem, if you will, for the optimal utility maximizing bundle, for the optimal bundle, the marginal utilities per dollar, the marginal, I'll just write it out, marginal utility per dollar will equal each other. And that's how we know that 4 and 3, for this problem, the optimal quantity of beer is 4, and the optimal quantity of pizza is 3. All right, we'll call it a day there and pick up on Friday. I had a question from somebody on some consumer surplus, producer surplus stuff, so if you want to come up here, I'm going to go over that as just kind of a review. Feel free to listen in. Okay. Which one do you want to start with? Probably this one of these. Probably the earlier ones first.
Someone asked before.
Which one did we start with? You had a question about this one.
Yeah.
Okay, so one thing I see right off the bat is you got a little wonky here with the,
Yeah.
It's awful.
So
Just a little.
technically, well, and that can cause some problems for the calculation of it.
Got that later on. It's like, oh, I'm
Okay.
a little off on my graphs there.
Okay.
But, I mean,
Let's
the
just
quadrants are
send a
still
little
high.
reminder. It's a little weird, but
Yeah.
this comes down here. Okay, so we're just kind of, and then you got the rest of that. Okay. Okay, so what's your question here?
Well, let me grab that other
Okay.
graph so that I can.
Yeah, and I've
Yeah,
got,
I did that right after class that day.
here, I've got this
Took
too.
me a couple hours.
You want this, Becky?
I'd rather have my own.
Okay. Yep.
Yeah, so I just took the subsidy directly from what we did in class.
Uh-huh.
And so then when I got it out on this graph, I was like, okay, so a subsidy benefits the producer. So how is it possible that we picked up for the consumer, we had ABC, now we've got all of these as well?
So the subsidy or tax creates a wedge between what the producer and consumer receive or pay, depending on which direction. And so the subsidy comes in, and where it touches the top part tells you the price that producers are going to receive. They're going to get $5,
Right.
but the consumer's price is going to fall to $3.
Oh,
That's the part you were missing here, and
Yeah.
that's what kind of made it, with drawing this wrong, it really would make it harder too. So here, we stick it in, we get those numbers lining up. And then that gives you the benefit to the producer of BCD. We're on this one, right? And then it also adds for the consumer FGHI.
okay.
Okay?
Alright.
And then let's see, you had another one with the.
Yeah, CG quadrants both for producer and deputy boss started because we had price before with government subsidy.
Government spending, yep.
Yeah.
And then there was more because they were spending money on the whole surplus.
We have plus. Yeah, so these were originally, this was originally producer.
Oh, yeah, back to free market, yes.
Right.
We had, actually, G was the producers, F, G, J, and ABC. And so that without the government spending, they lost all that.
So this is consumer.
Okay, and with the government spending, the government's going to buy all of that.
Okay, so the reason that you can have both dead weight loss and producer surplus in the same quadrants is because the government is.
Oh, yeah, it's possible to have them overlap.
Okay.
That's
I
where.
just didn't understand that overlap. It was like.
So with each problem, you really need to kind of go.
Like right here?
What happens to consumers? What happens to producers? What happens to government? And kind of get away from the how we started was that well that's a nice little triangle and that's a nice little triangle. There's no overlap. That's not necessarily the case.
Yeah, which is why I wanted to do these things individually, and I actually almost did each.
Yeah, I think this
of
is a
the
good idea.
graph separately, and then I went, you know what? That's gonna take me too long. This took me 2 hours, so
Yeah.
I couldn't do that.
Yeah, sounds like you got a good grasp.
Okay, well then that makes more sense then for my question.
Same
How
thing
we
with overlap.
occupy-
Yep.
yeah.
Yep.
Okay. All right. I was trying to put it in a form where I could.
Yep. No, you did a good job.
I was, I've had much problems with my structure sitting, but I couldn't do the PDF or whatever.
Okay.
So I like copied and pasted the debt snowball tracker to a Word.
Okay.
I mean, it looks different, but everything's still there.
Yeah, that's fine.
And like the persuasive essay and some of the stuff I did, and I put it in submission text.
Put it in what?
The submission, you know, the submission text on Blackboard instead of browsing your computer.
Oh yeah. You just cut and pasted it in.
No, I just typed it in the submission text.
Oh, that's fine.
Persuasive essay and stuff?
Yeah.
Okay.
Yep, that's fine.
And
The,
we have,
the problem with doing that is that if for some reason your computer glitches or something, you can lose. Like if you type the whole essay, then you can lose it.
I accidentally hit the backspace button after I was done. I had to retype the whole thing.
So yeah, don't recommend doing that at all.
Okay.
So try to do it in a separate document. Even if you do any sort of like even a text file document, whatever's basic, then you can open up that, cut and paste that into it rather than actually typing it. Yep.
Thanks. No, we have it. Is that test tomorrow? Open tomorrow? Or yeah.
Yeah.
And then you can take it all day, anytime.
Yep.